So hi everyone, this is Srikanth Yadav, working as Assistant Professor in the Department of IT, VFSTR Dmt U2 University. So in this data mining lecture series, in the previous videos we have covered the basic concepts of data mining and data pre-processing activities. Under data pre-processing activities, in this session we are going to see the basic statistical operations and statistical dispersion measurement operations that we are going to apply on the data are going to be covered in detail. Let's have a look at the basic information, basic points regarding this data activity. So before applying statistical operations or statistical measurements on the data, we'll see what is the basic definition of a data object. Now, what is a data object and what is an example for data object? Generally, when we are considering analytical activities or applying data mining activities on any data, it is a combination of a set of objects. We'll call it as a data set. So generally data sets which are made up of data objects. Data objects represents an entity in a database table. That means it can be a relevant information related to a particular database table. Now data objects typically we can describe and we can call them as attributes. That means every attribute will carry a uniqueness in the form of its value and its naming convention. Now data objects can also be referred as samples, instances, objects, values or data points. So during this pre-processing activity, we can use these words as synonyms for data objects. So data object directly we can call it as an attribute. So in simpler words we can call it as an attribute. Now what is an attribute in detail? An attribute is a data field representing the characteristic or feature of a data object. That means if you want to store any particular information, that information related characteristic and the feature of that value is going to be represented as an attribute. So here the data field representing a characteristic or feature of a data object, directly we can call it as an attribute. Now it is also called as a dimension or a feature or a variable. All these terms can be treated as attribute. So based on the scenario and the usage, we will use these technological terms in place of attribute. So we can call it as a dimension or a feature or a variable. Now under this, what are the different types of attributes which are available to represent the data? That is going to be covered here. Now here we are having the following four basic possible types of attributes. An attribute can store a nominal value, or an attribute is able to store a binary value, or we can store ordinal value or numeric value. That means these are the four commonly used type of value that is going to be stored using an attribute. We will see these individual type of attribute with suitable examples. First we will move to nominal attribute. That means when we are able to categorize or a group the set of values, we can call it as a nominal value. Each value represents some kind of category, code or state, and nominal attributes are also referred as categorical attributes. Example, if you want to represent or if you want to store a gender related information, the gender may carry three different values: male, female or transgender. Now for gender attribute there are only three possible values. Let us take, we want to represent state information of Indian country. When we are filling any online address application, when we want to choose the state of residing, there may be chance of possibility of having 29 states information. That means for that state attribute there are only 29 values. When we want to choose a pin code number, you may have hundreds of pin code values. Like that, depending upon that value and its count, the attribute value will change. Here we are having one more example called the marital status. When you want to choose any one of the value under marital status, the possible options may be provided here. Like if the person is a married one, he or she can select the married, or they can go for a unmarried, or they can go for a divorced, or they can go for widowed. So there are 4 possible values for marital status. Like that, if you want to choose an employee occupation, then based on the designation of that employee, they can choose that occupation. When you want to give an employee ID, then the employee ID may be in number or numeric character, and there may be more number of values. Here in nominal, for gender we are having 3 possible values. For marital status we are having 4 possible values. Let us assume for occupation we are having some 20 unique values. For employee ID numbers, let us assume we are having 500 employee numbers. If you want to enter the zip code, let us assume there are 2000 zip code values are there. And there is one more attribute, the hair color of a person. Let us assume there are 5 to 6 values are there, like black, white, gray. Like that, they can enter any type of that hair color. Now here in all these attributes, we can able to categorize the value, and we can store a numerical value, or we can arrange them in required format. So this is value, or these type of values we can call it as a nominal attribute. That means each value represents some kind of category, code or state. And the next one is the binary attribute. When there are only 2 possible outcomes, then we can use this binary attribute. Like if you want to represent true or false of a particular attribute, we can use this binary. Let us assume we want to store whether the student is passed in the examination or not. So we can use only 2 values. If the student is passed, we can use a variable or a class label called pass. If he is failed, we can use failed, or simply we can use P or F. So when we are having a possibility of storing 2 maximum outcomes, we can use binary attribute. Let's have the basic definition of this binary attribute. A binary attribute is a nominal attribute with only 2 categories or 2 states, and these states, if you want to represent numerically, we can use 0 and 1. If you want to represent in textual format, we can go for true or false. Generally, where 0 means that the attribute is absent or the attribute may not be available. 1 means the attribute is present. Now, binary attributes are referred to as Boolean if 2 states corresponding to true or false. Like if you want to represent, if you want to store whether the person is tested positive COVID or not, there are only 2 possibilities. If the person is tested positive, they can use binary 1. If he is not tested, he is tested negative, they'll use 0. So like this, depending upon the type of the value and the attribute characteristic and its feature, we can use the binary value. It can be 0 or 1, or you can go for true or false. So this is a subcategory of nominal attribute with only 2 possible outcomes. And next one. Now under binary, there are 2 subcategories. There may be, it can be a symmetric binary or asymmetric binary. Now what a symmetric binary will represent here? In both symmetric and asymmetric or non-symmetric, there are only 2 possible outcomes. Let us assume here a binary attribute is symmetric if both of its states are equally valuable and carry the same weight. That is, there is no preference on which outcome should be coded as 0 and 1. That means each and every state will have a equal, valuable and carry the same weight. So what is the meaning of this equally valuable and carrying the same weight? Just let's see this example here. Now here, for gender value, we want to represent the gender value into binary value. Like let us take, here we are having two values, male and female. Now if you want to represent that male in binary format, let us assume I took 0 for male, 1 for female. Now we have represented male string value as a binary 0. For female we entered as 1. There is one more alternative. Here the male value can be represented as 1, female value can also be represented by using 0. That means both values will have equal priority and we can choose any one of the value, either 0 or 1. Such type of attribute we can call it as a symmetric binary. So for male either we can use 0 or 1, for female we can use 1 or 0. There is no specific value was mentioned for that attribute value. And when it comes to the second type of binary is asymmetric binary. In this, the outcome is going to be represented with a specified value only. Like a binary attribute is asymmetric if the outcome of the states are not equally important. That means each and every state is unique value, so we can't take them as equal value. Let us assume when we are want to see the test results, one person undergone a medical test. Let us assume he was given some blood test to check whether he is having fever or not. So for this, if he tested positive, if the person is suffering with fever and the results came as positive, we can make it as a 1. If results came negative, that means he is not suffering with any type of fever, we can use it 0. But like in the previous example, we can't replace this value. Like means instead of 1, we can't write 0 here. Because when we try to make 0, the total meaning will become reversible, or you can say negative. Let us assume that the person is positive, we are using a binary 1. Instead of 1, if we use binary 0, that indicates that the person is not suffering with fever, but test results came as positive. That means there is no meaning between the value and its representation. So in asymmetric binary, values must be represented with its specific format only. That means both outcomes will not have equal importance, because testing positive is not equal to testing negative. Both are different. So in this case, when we want to use a binary representation, we have to fix only one type of representation. If the person is tested positive, we want to represent, use only binary 1. Don't replace that 1 with 0, because these two are not equally important with each other. Such attributes are called as asymmetric binary. And another type of attribute is ordinal. So when we want to represent or store or access the attribute value in an order, then we can call it as a ordinal attribute. That means either in the format of usage or in the format of data entry, the order should be followed strictly. Now, what is this example here? An ordinal attribute is an attribute with possible values that have a meaningful order. Like when we want to give a ranking to a particular product, let us assume here we want to give a ranking for a university on the scale of 1.0 to 5.0, and the values may be in the form of order only. That means after 1 we will get 2, 3, 4 and 5. That means there is an order following from lower to highest value. Let us say we want to pick 5.0. Now this can also be represented in reverse order. Like we will give 5.0 is the initial value, later we are decreasing its representation. Both can be used, but in both cases there should be the meaningful order should be followed while giving. Like when we want to give a grading to a product, like let us say grading on the scale of A to E, like A, B, C, D, E. A indicates the highest grade value, E indicates the lowest grade value. So if any person gives grade A, let's say the product is having very good grade value, they can also represent in reverse order like E, D, C, B and A. But any one order we can follow, but strictly we have to follow its order. We can't jumble the values. Such are called as ordinal attributes. The attribute with possible values that have a meaningful order or ranking. So this is called ordinal attribute. And next one is numeric attribute. The name itself indicates that we are going to store some numerical information. Like it represents the quantitativeness of the data. A numeric attribute is a quantitative, that is, it is a measurable quantity represented in either in the form of integer or a real value. Like if you want to store salary of an employee, we can use float value. If you want to represent price of a book, we can use float value. If you want to enter age of an employee, we can use integer. If you want to enter mobile number of an employee, we can use integer. Depending upon the quantitative value and its representation, either we can use an integer or we can use a real value. And the numeric attributes can be two categorized. That means whatever numeric values we are going to store, either it can be an interval scaled attribute or it can be a ratio scaled attribute. Depending upon the type and feature of that value, either we can call it as interscaled or ratio scaled. Now we'll see what is an interval scaled attribute. That means these values are measured on a particular scale of equal size units, and the values are interval scaled attributes, have an order and can be positive, 0 or negative. Example here, when we are representing a temperature, it can be Fahrenheit or it can be Kelvin. When we are storing the calendar dates between 2 years, we can follow an order. That means there is a range, we can divide the values and we can measure the values within the given range. Those are called interval scale. And here every attribute may not have the equal interval. Let us assume for calendar dates, if you are taking complete academic calendar, the calendar dates may differ. If you are considering financial calendar, the dates may differ, but number of days may be same, but starting and ending and the range of values will differ with each other. Such are called as interval scaled attributes. And next one is ratio scaled attributes. That means this is another way of storing a numeric attribute with inherent 0 point. That is, if there is a measurement is ratio scaled, we can speak a value as being a multiple of another value, like how much percentage of sales have been increased compared to the previous year. This is our question. We want to see how much percentage of sales have been increased when compared with the previous year sales information. Let us assume there is a hike of 20%. Here we are representing that increase of sales information in the form of a percentage, that is called ratio scaled. That is 20 times of that previous value, 20 into x. Example, temperature in Kelvin, length, count and all monetary quantities can be treated as a ratio scaled attributes. Now till now we have seen 4 types of attributes, like numeric, binary, under binary we have seen symmetric and non-symmetric, and third one we have seen ordinal attributes. Now last we have seen numeric attributes. Under numeric we have seen interval scaled and ratio scaled. Now there is another way of observing these attributes, whether the attribute will follow a discreteness nature or continuous nature. Depends on the type of the value and characteristic of that value, we can categorize either it is a discrete or it can be a continuous. Let us see these two with suitable examples. A discrete attribute has a finite or countable infinite set of values. That means for a discrete value, there may be a range and the values can be counted. Let us assume when we are trying to enter age of an employee, or whenever you want to choose age of an employee, generally we can go with this 0 to 100. Definitely there will be a question arise. What value will choose if any person whose age is more than 100 years? Here we are talking generally. In general scenario, if you want to fix that age range, we can go for 0 to 100 years. Now here there is a finiteness of this range, finite and countable infinite set of values which may be or may not be represented as integers. Binary attributes are special case of discrete attributes like zip codes. All zip codes are pin codes. Profession, under profession, if you are try to entering 20 different types of professions, then there is a 20 countable values and there is a set of words in a collection of documents. So here, other than numeric, other than integer, here we can take it as maybe or may not be an integer, but there is a countability of the value. Like age, we can have like countable value. Like for zip code, you will have a countable. Like for profession, we will have some values like maybe teacher, maybe doctor, lawyer, scientist. Like that, you will have fixed number of professions. When there is an attribute which is not in a fixed finite nature, we can call it as a continuous attribute. If an attribute is not discrete, we can call it as a continuous. It has real numbers as represented as floating point values like height of a person, weight of a person, temperature. We can't fix that value. The value may vary based on that person and the value will have a real value nature. That means decimal part is also available in the data. When we are unable to make as a finite count of that attribute, we can call it as a continuous. Like temperature, weather forecasting, scientific calculations, salary information, weight of a person, height of a person can be treated as a continuous attribute. So these are the two different types of attributes can be categorized based on its characteristic. Next, we are moving into the measuring the central tendency of the data. When we are dealing with large amount of data or large amount of numerical data, how can we measure the basic statistical perception of the data or basic statistical dispersion of the data? So to understand and to analyze the basic measurement dispersion of the data, here we have to use some basic statistical measurable formulae. Under this measure central tendency of the data, the first and foremost attribute or measurable quantity is mean value. Generally we will call it as a average. So when we are able to find out average of a given set of values, how it is going to be done? The most common and effective numeric measure of the center of a data set is mean. That means we want to find out average of all the student marks. We want to find out the mean value of all the student marks. So here marks are in numeric nature. For that numeric valued attribute, we want to find out the mean value. Now, what is the basic formula here? Here the basic formula here, take the sum of all the values like x1, the first attribute value, x2, and we can go for up to last element of that set. What we are taking? We are taking the sum of all the values divided by total number of values which are participated in the data set. So precisely the total equation we can represent it in a simplified manner using a summation function. Sigma I equal to 1 to n x of I. So this summation function will take sum of all the values divided with total number of values which are participated, and the resultant we are representing with as x bar. In some cases we can use mu also. So this is the formula to calculate arithmetic mean of a numeric attribute. Under this mean, we will see one small example here. Suppose we have the following values for salary. The salary values are represented in thousands of dollars. That means here 30 indicates $30,000. Now, what is the fundamental formula here? When we are dealing with basic central tendency and central measurement of any numerical data, the first and foremost activity is, let us arrange the given data in a ascending or descending order. So it's not a compulsion, but if we arrange the data in an order, we can get results more precisely and accurately. So here we arranged all the salaries in increasing order. Now for all these increasing ordered values, we are going to calculate the average of that salary information. So here we took all the sum of all the values which are arranged in ascending order, and we got the sum as 696. And total number of elements which are participated are 12, so we got 58. Now here 58K dollar is the mean value of the given data set, because we are representing values in thousands of dollars. So here 58K is the mean value of that salaried attribute. Another measurement of the central tendency is median. That means find the mid value or midpoint of that data set. We will call it as a median. Now here we are selecting an attribute called asymmetric, which is skewed data. Now what is the use of this median? We are able to find out the center of the data. The center point of the data we can calculate or we can obtain by using median formula. Now what is the formula for median? Here the formula for median is, it depends on the number of elements which are participated. If number of elements are in odd number, directly we can pick the mid value. If number of elements are in even number, take the average of middle two values. Here in this example, suppose we have the following values for the salary in thousands of dollars. Totally we are having 12 values here, starting from 30, 36, last one is $110,000. These are the 12 values. When the number of values are in even numbered, here 12 is the even number, take the average of middle two values. So here the middle values are 52 and 56. The sixth and seventh value 52 and 56. Take the average of these two values, like 52 plus 56 divided by 2. Here we will get 54. Here 54 indicates median of that given data set. 54 is the median of the given data set. We can say center point of the data. So this is another measurement that we can use to find out central tendency of the data. And the next one is the mode. Mode is another measure of central tendency. Mode for a set of data is a value that occurs most frequently. That means from the given set of values, value which is repeatedly occurring or most repeated value, we can call it as a mode. Let us see this example here. So in this salary attribute, totally we are having 12 attributes. The same example we are continuing. Now among these, let us find out value which is repeatedly more than once or twice. If you look at carefully, value 70 which is repeated twice, and there is one more value which is repeated more than one time, that is 52 is repeated 2 times and 70 is repeated 2 times. So here in the given example we are having two modes, they are $52,000 and $70,000. That means these two values are repeated 2 times. Now in this case there are different categories of mode values. They are data set with 1, 2 or 3 modes respectively called as unimodal, bimodal and trimodal. That means data sets with 1 mode value, here we are having 2 mode values, we can call it as a bimodal. If you are having a mode which is repeated 3 times, we can call it as a trimodal. So this is called, in general, a data set with 2 or more modes, we will call it as a multimodal. So the mode indicates, or mode is used to find out the repeated value or repeated numeric value in the given data set. And next one, to measure the dispersion of the data. Till now we have seen central tendency of the data. We used mean, median and mode. Now to find the range of values or to observe the range of values for the given data, we can use dispersion of the data. How best the data has been dispersed on a coordinate plane if you are able to draw it. In this dispersion measurement, we are having an attribute called range attribute. Let us assume we are having values called x1, x2 and so on up to xn, a set of observations for some numeric attribute called x. That means we are having x is an attribute, under x we are having values like x1, x2 and so on up to xn. Now range of that set is difference between the largest value and the smallest value. Let us assume we arranged all these values in ascending order. This will become the minimum value and the last will become the maximum value. Now range can be find out the difference between the maximum, that is xn minus x1. We can call it as a range of this value. This xn is the maximum value minus minimum value. Maximum minus minimum. The difference between maximum and minimum, we can call it as a range. Now one more measurement that we can use to measure the quantiles of the data for dispersion of the data. Now what is this quantiles here? Quantiles are the points which are taken at regular intervals of the data distribution. When we arrange the data in ascending order or descending order, for a regular interval of time, how and what amount of data has been distributed by dividing the data. Let us assume we will take 100 quantiles, commonly referred as percentiles. Let us observe this graph here. So in this graph, we are trying to represent the distribution of the data. Let us assume this is the starting point of the data and this is the last point of the data. Under this distribution, for every regular interval of time, like we are taking Q1, Q1 indicates 25th percentile of the data, Q2 indicates a median, or you can take it as 50th percentile of the data, and Q3 we can call it as 75th percentile of the data. That means at regular interval of time we want to see the distribution of the data. We can also go for any percentile. It's not compulsory we have to calculate only 25, 50th and 75th. We can also calculate 30th percentile or 70th percentile in the scale of 0 to 99. Because we are starting with 0, we can't go for 100. It can be 0 to 99 only. That is called the quantiles. For a quantile or for a particular portion of the data, what is the distribution of the data here? So this gray shaded graph indicates, or portion indicates, the 25th percentile of data distribution on the scale of 0 to 99. Now these quantiles are used as the data dispersion measurement. Now under this dispersion, we encountered three commonly used percentiles, that is Q1, Q2 and Q3. So Q1 indicates 25th percentile of the data, Q2 indicates 50th percentile, sometimes we will call it as a median, and Q3 indicates 75th percentile of the data. When we take the difference between Q3 and Q1, we can call it as a interquartile range, that is called IQR. So here let us have the definition here. The distance between the first and third quartile is a simple measure of data which is spread on a given range covered by the middle of the data. This distance is called interquartile range and it can be defined as IQR is equals to Q3 minus Q1. And let's see this example. So for the given example, what are the quartile values and what are the IQR values here? So in the same example that we have seen in the previous slides, we took the salary values which are in the range between 30 to 100. Totally we are having 12 unique values here, and we contain 12 observations already sorted in increasing order. The quartiles of this data are 3rd, 6th and 9th values respectively in the sorted list. Therefore Q1, what is the third indicates? Third indicates third quartile of the data, that is Q1. Next, Q3 is 63, that is 9th positioned data. When we try to divide all the 12 values into 4 groups, in the first group we are having 3 values. The Q1 indicates the 47, that is the third value. 52 indicates that is Q2, and 63 indicates Q3. So here Q3 is $63,000, Q1 is $47,000. So we got Q1 and Q3. Now if you want to calculate IQR, substitute Q3 minus Q1. 63 minus 47, we got $16,000 as the interquartile range for the given example. So in this way we can subtract Q3 minus Q1 and will obtain IQR value. Using these quartiles or percentiles and IQR, we can predict the 5-number summary. Sometimes it is also called as box plots. 5-number summary is one of the data distribution which is used to measure dispersion of the data in the following order. The 5-number summary consists of median, that is Q2, quartiles Q1 and Q3, minimum value, that is smallest, and maximum value, that is largest. So totally we are taking 5 values, which is minimum value in the given data set, comma, Q1 of the given data set, median of the given data set, Q3 of the given data set, and maximum value of the data set. So totally we are taking 5 measurable quantities: minimum, Q1, median, Q3 and maximum. If you arrange all these values in a graphical representation, we can call it as a box plot. Box plot are a popular way of visualizing distribution of the data. The box plot incorporates 5-number summary as follows. So all these 5 values we are going to represent in a graphical representation format. That format we will call it as a box plot. Now what a box plot will contain? Typically the ends of the boxes are at the quartiles. That means when we draw a box, the ends are called as quartiles. Let us assume it is Q1 and Q3, definitely it will be a median here. That is a meaning here. The median is marked by a line within the box. Two lines called whiskers outside box which are entered. So here outside of box we are drawing two lines. One will indicate the minimum. Second one is going to be represented as maximum. That is smallest and largest observations. We will see this with example here. So as we discussed, in box plot, we are trying to draw a box here. The border of the box is called as quartile. So let us, if they took this border as Q1, then upper border we can take it as Q3, or we can also take reverse order. You can take it as Q1 or you can take it as Q3. So let us assume here we took Q1 as the first border, Q3 is the second border. In between these two Q1 and Q3 we took the median. Median is the IQR, interquartile range, and the minimum value of the data set, maximum value of the data set are attached to this box using some lines. Generally we will use dotted lines. This line is called as whiskers. So the total layout is called as a box plot. So here what we are trying to do, here we are representing distribution of the data in a visualized format. Here in this representation we are using a box notation, that is Q1, Q3, median, minimum and maximum in an order. First we are having minimum, quartile 1, median, Q3 and maximum. Q1 and Q3 are the borders of the box. Minimum and maximum are the extended values of the box which are connected by using some straight lines or dotted lines. We will call it as whiskers. If any value which falls beyond minimum or maximum, we will call it as an outlier. The value which is not able to represent in this given minimum and maximum boundary. So this is the way representing the value using a graphical format called box plot. So box plot is a visualized method which is used to represent 5-number summary. So this 5-number summary can be used. So here when we move to higher level dispersion measurement of the data, we can use this formulae called variance and standard deviation. So here we can use variance and standard deviation as the central dispersion of the data. So variance and standard deviation are measured of data dispersion. They indicate how spread out of a data distribution. Now what is the formula here? Now what we are going to apply here? Let us analyze this given equation. Here xi indicates individual value of the given data set. Let us assume we are having values like A, B, C, D, like that up to n we are having. Now for this given data set we want to calculate the variance. Now the first value, let us assume this is xi, is subtracted with x square, that is mean value of the data set. Subtract every value with its average or mean value and apply the square of that. When we are applying the square, what will happen? The negativeness of the data is going to be eliminated. That means only absolute values will come here. And we are repeating this process for all the values. Sigma I equal to 1 to n xi minus x bar whole square. Once the summation is completed, we are taking sum of squares divided by total number of elements which are participated in the given data set, that is capital N. So you will get sigma square, that is variance. If you apply square root, you will get standard deviation. The formula for sigma square equal to 1 by n into sigma I equal to 1 to n xi minus x bar whole square. Let's consider this example. Here, when we are measuring the dispersion for the given salary values, which are starting from $30,000 to $110,000, the variance formula is sigma square, that is, take the squares of each and every value, subtract with. So there are two variations here. We can take 1 by n into sigma I equal to 1 to n xi minus x bar whole square, or we can also use the second one, sigma I equal to 1 to n xi square minus x bar square. Both will be the same answer. We can use this formula or this one. We can do individual subtraction squares of every value, or you can take sum of all the values, that is sum of squares, and subtract with the mean value. Both can be used. After calculating this sigma square, we got 379.17. If you apply the square root, we got 19.47. 19.47 is the standard deviation of the given data set, that is salaried data set, which is having 12 values. Now, how can we measure the dissimilarity between the numeric data? The most popular distance is Euclidean distance. When we want to measure similarity and dissimilarity between the numeric data, we can use Euclidean distance. Now, how this Euclidean distance are going to be calculated? The same manner whatever we had done in the variance, the numerator we are repeating here. That is, subtract every value with its distance, that is x1 minus y1 whole square plus x2 minus y2 whole square, xn minus yn whole square. That means we are taking the subtraction between x coordinate value and y coordinate value, and we are squaring of it. When we apply squaring, we will get the absolute value, and we are repeating the process for all the elements of the given two data sets, and we are taking the square root of it. It will give the Euclidean distance. Now here we are taking only two attributes, that is x and y. Let us take example of another one. In addition to Euclidean distance, we can go for either Manhattan distance or we can go for Superbomb distance. In Manhattan distance, the Manhattan is also called as a city block or city distance. Here, how the distance is going to be measured between given two data points, that is I and j. So here each I value xi1 and xj1 is subtracted. If you look at carefully, we have done the same thing in Euclidean distance, except we are not squaring here. Directly we are taking only absolute value. So xi1 minus xj1 under mod will give the absolute value here, and we are repeating this process for all the values. This is called Manhattan distance. In Euclidean distance, we took the same procedure. We applied square of that each and every difference between two data set values, and finally we applied square root. But whereas in Manhattan distance, instead of applying squaring and square root, directly we are taking mod of that value, subtracting equal data points in both data sets, that is I and j. And there is one more distance that is called as a superbomb distance. Sometimes we will call it as L norm distance. The superbomb distance, the simplified formula is like this. Take the maximum function of xif minus yjf. That means repeat the process and take the maximum value of this difference. When we took the difference between first two values, repeat the process for all the n values, whichever will give the maximum value. That maximum value we can take it as superbomb distance. So here the formula is sigma f equal to 1 to p xif minus xjf whole to the power of h. Here h value will be given at the time of calculation. If they give h value equal to 2, we have to replace that value with 2. And another dissimilarity measure is the cosine similarity. Cosine similarity is taken as in this manner. It is a similarity that can be used to compare documents, or say give a ranking of a documents with the respect to given vector of queryverse. So when we want to perform a ranking on a given set of documents or a digital content, we can use cosine similarity. The formula is x dot y. Here we are taking a vector multiplication between x and y dot product followed by mod of x into mod of y. Take the dot product between two data vectors, that is x and y, and take mod of x and mod of y. Will give the cosine similarity. Now look at this example for cosine similarity. Here we are having two documents, that is x and y. Under x and y we are having some values. We are having 10 unique values in each and every case. The cosine similarity between two vectors can be obtained. Here we are calculating numerator x dot y, that is we are applying vector product 5.3, that is we are multiplying first value in x and first value with y. So 5.3, 0.0, 3 into 2, like 0 into 1. Totally we got 25. And we are taking double mod of x, which is we are taking the cross product of the value, that is value. How it is going to be done? Take the square of each and every value and add with the remaining values, like 5 square plus 0 square, 3 square, like that. If you apply, we got double mod of x, which is equal to 6.48. And if we repeat the process for y also, that is double mod of y, we got 4.12. And the similarity, if you substitute all the values, 25 divided by 6.48 into 4.12, if we calculate, the resultant value will be 0.94. Now that value we have to observe how much the documents are similar with each other. So there is 94% there is a similarity in the given data vectors. So this is the summary. That means in this unit number 2, we have covered the following concepts with detailed relevant examples. We observed basic data cleaning activity, and we have seen what are the basic data quality measurements. Under data cleaning, we have seen missing values, noisy elements, inconsistent values, and handling of missing, noisy, inconsistent values. And next one, we observed data integration process. Under data integration process, we have seen entity identification problems, removing of redundancies, observing inconsistencies among the data. And third, pre-processing activities, data reduction, how best we can reduce the data. So we applied dimensionality reduction technique, numerosity reduction technique, and data compression techniques. And finally, fourth attribute we have seen data transformation and data discretization. How we can convert data format, that is, how can we apply various types of normalization techniques and how can we represent the data in hierarchical representation format. In addition to this, we have seen statistical measurements of the data. Either it can be central tendency or measuring the median and dispersion of the data. So these are the concepts we covered in this session. These are some of the references which will help you to find out the basic fundamental information related to data mining and data warehousing and data quality related activities. You can refer these basic fundamental reference books and papers. It will help you a lot. And thank you. So in this session we completed data mining lecture series and we applied various data pre-processing techniques. In next session we will see data mining related association activities. How can we apply basic association rules and how can we derive association rules and what are the various algorithms which have been proposed and association analysis will be covered in detail. Thank you.